Hey guys, so one of the things that we're talking about in our kind of rubric is how can you take a situation or a word problem and turn it into a graph and a table and an equation. So a lot of the word problems when we talk about quadratics are going to be talking about area, right? Because we know a quadratic is going to have a variable being squared, and area is also going to have those variables being squared. So this question is talking about a garden measuring 12 by 16, and we're putting a pathway around it. So let me highlight this pathway. This is the pathway around it. So we know the size of the garden, but we do not know the width of this pathway, and it's going to be the same width all the way across, so we're just going to call it x. But we know that it increases the total area to 285 square meters, and we're trying to figure out what the x is. So the first thing when you are taking a situation and you are trying to turn it into a table, a graph, and an equation is to draw a picture. When in doubt, draw it out. So that's what we kind of did over here. And then kind of what you can see, what this question wants you to see is, now I'm going to go over this blue. If we look at the new width, we know from here to here is 12, and we also know then we have, let me pick a different color here, then we have this from here to here, which we know is x, and we have this from here to here, which we also know is x. So we're going to call our new width, and it's going to be the width because it's the shorter side, this new width is going to be 12 plus 2x. Okay? And you can extrapolate from this when we do the longer side, or the width of 16. Don't forget, we're also going to have an extra x on this side, and we're adding an x on this side. So the new width is going to be 16 plus x, which is plus 2x. So we said what? The first thing is draw a picture of this hitch. Draw a pic. Okay, what's the second thing I'm going to do is I'm going to label it with any numbers that I know or can figure out. Label pic. Okay, and this next thing I'm going to ask you to do is think about, are there any formulas that you can use to figure this out? Well, we're trying to find area, right? So I know, and this shape is a rectangle, so I know that the area of a rectangle is equal to the length times the width, and that's something we've been working with a lot. So let's just, in this equation, look, we're building an equation. Right now we are taking a situation, we're making an equation out of this formula. I already know what my length and width are, and actually I already know what the area is, right? Because the problem tells me the area. It says it's 285 square meters, so we're dealing with meters here. I was thinking feet in my head. But here we have 285 square meters is equal to the length, which is the longer side, so we'll call that 16 plus 2x. We already figured this out, right? 16 plus 2x times 12 plus 2x. Now, this is an equation, but this is not an equation that we could put into the calculator, because to do that, we would need to have y equals to something. And right now we have that 285. So you know what we should do is let's just make this 0, because we can use y or 0. Those are the solutions to an equation where the graph crosses the x-axis. Okay, so to make that 0, we're going to need to subtract 285 from both sides. Okay, and that makes this 0, or we could put y in later, equal to, and let's just rewrite it, 16 plus 2x times 12 plus 2x, and then we'll just tack on this minus 285. Now, if you're using a calculator, don't even worry about doing any more computations, because you could accidentally mess it up, right? So you could just put this into a calculator. Let's do that actually. Let's put it into Desmos. Okay, and it was parenthesis 16 plus 2 x. And, you know, quite honestly, it could be 16 plus 2x in the first, or it doesn't matter which way your parentheses, which parenthesis comes first, because we're multiplying. But since the formula is length times width, that's why I did this. And then we have 12 plus 2x. Okay, there's our parabola, but don't forget we need to minus 285. Okay, and then I'm going to zoom out here. Okay. Zoom out some more. Look how far, you know, I want to zoom out to show you how far down it goes. But, so it goes down here. My vertex is -7, -289. Okay, but what I really need to know, oops, zoom back in, go back to the top. What I really need to know, my solutions, or the x values, are going to be here and here, right? So I have two x values. This parabola crosses the x-axis twice, once at 1.5 comma 0 and once at -15.5 comma 0. So what I'm doing now is finding my intercepts, because if I have my intercepts, I can make a graph, right? So, well, I guess we didn't need to graph it. I just wanted you to show it crosses twice. Let's finish solving this problem first. So our x-intercepts that we solved from the graph was -15.5 comma 0 and 1.5 comma 0. Now here's the deal. There's only going to be one answer for this. You need to use your common sense. Is our x going to be -15.5? What are we trying to find? We're trying to find how wide this walkway is. We're trying to find how wide this walkway is. -15.5 doesn't mean anything in this situation. So even though it is a solution, it is not a solution that we're going to be able to use. What we know is the walkway, and always answer in complete sentences when you can, right? The walkway will be 1.5 meters wide. Will be 1.5 meters wide. Okay, the walkway will be 1.5 meters wide. We've solved it. But we also want to talk about how can we take this equation. We took this situation and we made an equation, right? That was one. How can we take this situation and make a graph? Well, it all goes back. I'm going to erase some of this stuff. It goes back to being able to solve this equation for 0. Because if we can solve this equation for 0, then we'll know, and we can create that table. So we're two birds, one stone here. Then we will know where it's gonna, what it's going to look like on the graph. If we make this table, then we can graph it, right? So we're going to have to simplify this equation. What that looks like is using the area model to multiply these two sides together. And I'm going to do that, and then I'm actually going to pause it so that I'm not wasting minutes on this video doing the area multiplication. All right, you guys, so I did my area multiplication of these two parentheses, and I got 4x squared plus 56x plus 192. Now, do not forget, this is important. I still need to subtract 285. Okay, so let's simplify this again. 4x squared plus 56x. And then it's going to be minus, because 285 is bigger. And just doing that in the calculator, 93. Minus 93. Okay, and don't forget that we're trying to find out where those are 0. But I know one point, if x is 0, I know that my y is -93. I know that's going to be the y-intercept. For the rest of it, the easiest thing to do here, it's not factorable. And it's going to be, it would be really tricky to complete the square because of this 4. Well, it wouldn't be that tricky, but I'm going to show you guys, we're just going to use the quadratic formula where you use A. We're not going to use the quadratic formula, B and C. We're just going to put these numbers into quadratic formula calculator because right now I'm not trying to teach you how to solve this. I am trying to teach you how to turn it into a table and then a graph. So right now what we're doing is A is 4, B is 56, and C is negative 93. So I looked up this calculator. So A is 4, B is 56, and C is negative 93. And we're going to hit calculate, and we'll learn how to do this on our own. And our answers, the same answers we got from that graph, right? Our x equals negative 15.5 as one answer, and x equals right here, and x equals 1.5. So there's our two answers right there. We will learn how to do this. So we have 0 when y is 0, x can be both negative 15.5, and it can also be positive 1.5. Now if I find the average of those two numbers, that will give us the middle. So I know this is, if we want to sketch our graph from it, which we've had plenty of practice, if this side's, oops, let's not use this one because we know that it is. All right, what was I just trying to do? The average of 1.5 plus negative 15.5, enter, divided by 2. You have to enter first for order of operations, negative 7. So that's our x value. Okay, and we need to figure out when our x is negative 7, what is our y going to be? Hold on, I'm going to pause this and draw it correctly. Okay, so if our x value is negative 7, you can just look at your calculator. Okay, and I want to remember we're going to input into our equation. So let me highlight the equation I'm going to use. We're going to input into our equation right here 7 instead of x. So, and I'm just going to put it in just like this. 4 times 7 squared plus 56 times 7 minus 93. And it should be lower than 93. Oh, crap. You guys see what I did here? And I'll just bring this back again. I didn't put negative 7. It's important. Okay. Now we've got to be second insert negative 7. Second insert negative, enter. Good, negative 289. So coming back here, in my little graph here, I'm going to go negative, oh, this doesn't look good, negative 289. It's not, my negative 93 should be up here then, just to make things look a little bit better. And then how about we use a highlighter to, this is going to be the farthest down it goes, but it has to go through here and here. So it's going to look like, oh, this is a terrible drawing, you guys, but there you go. So we have created a table. Oh, and I can add another point to that. I can add my negative 7, negative 289. We've taken a situation. We have created an equation. That's what I highlighted in yellow. We have created a table right here. And we have created a sketch, all from just the situation. Okay?